What we covered last time in the last few videos was the merge operation. And what the merge operation did for us was, let's say we had an array A and an array B, both of which are sorted, and we ran it through this merge method. I'm just going to black box it here. We ran it through this merge method. Then what we could get out as the output would be A union B sorted. Right, and what this union just represents is the two decks or the two arrays were put together. Right, we combined the two decks of cards and got a sorted deck. And so what we're going to do is we're going to apply what we learned there to this new problem of sorting an array. Right? And to be clear, just to differentiate it from this merge input, in merge, our input was two sorted arrays. And what we're going to do now is we're going to consider the problem where we have one unsorted array, and we want to turn that into a sorted array. And somehow we're going to utilize that merge method. So let's just imagine for a second that you're given a task. And you have, somebody gives you, let's say, a deck of cards, right, representing this unsorted array. And this deck of cards is a really large deck of cards. This deck of cards actually has, let's say, 1,000,000 elements in it. It's a size 1,000,000 deck of cards. And somebody asks you, can you, well, so first of all of the cards in there are unsorted. And they all have a unique number between 1 and 1,000,000. And somebody asks you, hey, can you sort these numbers for me? And so one thing you might say here is, I don't know how to sort an entire array of 1,000,000 cards, or an entire deck of 1,000,000 cards. But what I did learn in these last few videos was that if you somehow split this deck of card of or this deck of cards of 1,000,000 into two separate decks of cards, and you somehow sorted them, then I do know how to sort it, right? I just pass these two sorted decks of cards into my merge operation. And so that intuition right there, I'm going to actually write this out, that intuition, which is kind of what we say is, I don't know how to sort. Let's give this deck of cards a name. Let's just use D for deck. Right? This D stands for our deck of cards. We say, I don't know how to sort D. But if you split D into two decks and sort those decks, then I'll just run the merge operation, right? And so now our problem just got reduced a little bit, right? So whereas before our problem was to sort this deck of 1,000,000 cards, now our problem is how do we sort two partitions or two separate decks of cards, right? And so what we're going to do is we're going to define some pseudocode here. Let's say we wanted to sort this deck of cards D. What we're going to do first is split D into two decks. What we're actually going to do is split D in half. And we're going to cut it right at the 500,000 mark. And we're going to give it a deck A and a deck B. All right, and somehow we want to sort both A and B so that we can run the merge operation on it in order to get our sorted original array. And so what we're going to do is we're going to notice that, well, we've already defined a sort method here, right? This sort method is a general all-purpose method for sorting any sort of array. And so we're just going to reuse that here. So we're going to say, we're going to let this variable sorted A equals sort on A, and we're going to do the same thing with B. All right, that's the equivalent of us splitting D into two decks and sorting those decks. Well, now we know exactly what to do with these, right? We've already been over this. We're going to run we're going to say, we're going to have this variable result, and we're going to let that equal to merge of the two sorted halves. And now we output the result, and we are done. I say we are done, but I think we're missing one thing here, which is a base case. As you can see, we've defined a recursive method here, where inside our method, we call that same method. And so if we were to leave this as is, we'd get sort of D calling sort of D split in half, calling sort of that split in half, on and on and on, and this would never stop, right? This would be this would lead to infinite calls of this sort method. And so we have to stop somewhere, and the intuition behind where to stop is to look back at this quote that we have, right, which is, I don't know how to sort D, but if you split D into two decks and sort those decks, then I'll just run the merge operation on them. And the key thing we need to look at is the I don't know how to sort D part, right? The reason we didn't know how to sort D was because it was a million cards long. There's a million cards in it. There's no way we're going to just be able to look at it and know how to sort it. But there is a case where we do know how to sort it. A very trivial case. And I'm just going to place that piece of code right into here. And that trivial case is if our deck of cards is of length 1. Right, because if I were to give you just one card and tell me to sort that one card, you'd probably just first of all look at me funny, and then just hand that card back, saying, you know, that card itself is sorted. So that's what I'm going to put here, which is if D is of length 1, just return yourself, or just return D. Return that one card in D. And so that right there is the basis of the merge sort function. Right, what we've defined here is actually merge sort. This is what merge sort is. And there you have it. This is a recursive way of sorting an originally unsorted array of numbers.